Our first speaker today is Ed Boesiger. He's with Lockheed Martin Space. He's going to be talking about space mechanisms. Mr. Boesiger has worked on dozens of satellites for Lockheed Martin over his 37-year career that started after his 3 degrees in mechanical engineering. He's a senior technical fellow for the corporation, and when he's not doing that, he's traveling, hiking, and camping. He's visited all 50 states and 65 countries. So please welcome Mr. Ed Boesiger on space mechanisms.
Good morning. So on the connection here, obviously, this is not a green technology that you'd normally think of, but with space mechanisms and satellites, they're always looking at the Earth and determining lots of different areas to help environment and that kind of thing. So I'm going to talk a little bit more about details on some space mechanisms to get you excited about engineering. And you can see in my background is what I worked on, which is the space station solar arrays. And I'm going to share a screen now on maybe some other information. Let's see if I can get the full screen. Should be seeing, that may be a problem with this full screen. Hang on. Hang on. Let me just do share it. Let me just do this. It went into all my other screens.
Not a problem. That looks good.
Okay. All right. So as Kathy said, I worked with Lockheed Martin Space in Sunnyvale, California, and work on satellites for the last 37 years. And particularly with mechanisms, so talking about mechanisms, it's really anything that moves. So, yeah, it's your door hinge, but for satellites, we're talking about things like release mechanisms because we go up on a rocket. So going up on a rocket, it's rattling us quite a lot, but that's not very good for making things stay together. So we have release mechanisms that hold things down during that time and then release them when you get on orbit. Those things may then deploy and rotate and move to different places. We may get rid of things, jettison and separate. Well, particularly the spacecraft has to release from the rocket, so that's one thing. We have things that point and track, all those instruments that are looking at the Earth or Mars or wherever, or even just the solar arrays that have to move around to keep tracking the sun. And then what we call utility transfer. There's things that power or data or electrical or antenna signals have to move across a joint. A lot of times now we're moving fluids for things like on lunar missions and things like that. I guess this all works. So I don't know if you can see the movie, but it's, you have things that will deploy off in different directions, motions, and everything has to be stowed up for launch and then kind of expand. And so and things move. And so this all sounds like, okay, well, those things you can go buy at Home Depot, right? Well, not quite. There's a lot of challenges to what we're talking about here on space mechanisms, and here's a few of them. One, a lot of the technology that we're talking about is really not taught even in school. Even in my 3 degrees in mechanical engineering, a lot of things didn't come across in that. I learned it at work, a lot of the details and things that you end up and you're continually learning throughout your career, still learning. These are all what we call mission critical. They absolutely must work or the satellite is useless. And so a lot of more details and more analysis and more engineering goes into them for that reason. Some temperatures, we can get things that need to move near absolute zero to things that move at very hot temperatures. We have to deal with radiation that we're all protected from on the Earth, but not so much in space. our toolbox of materials is limited. Michael's there inventing new materials for hypersonics and things, and we do too, but we are very mass limited, and we have to work in vacuum. And so other things that they have to be fairly strong to survive that launch vibration I talked about. And even after not just vibration, but as you do those separations, and especially on the rocket, you get these explosive pyroshocks to many thousands of Gs, and that has to work as well. And we can't fix it once it's launched. We can't get to it. So there's that. I mentioned vacuum. Lubrication, so it has to work a long time in space, like 15 years, and only certain particular lubricants are allowed, and you can't replenish them. Sometimes these are very high precision, working in nanometers. You'd think, hey, we don't have to deal with gravity, it's easy, except you have to test it on the Earth. So now you got to deal with both things. And because we're up in space, very little power is available. As an example of kind of things that we have to deal with, here's a comparison of, say, here's an oil film that we have between rotating surfaces. That's very typical. You can see it's a very, very small number, micro inches. And in comparison, some different things in that same scale. So here's your fingerprint, and that's obviously much larger than that gap. And so, and then you think about dust, and then even geez forbid a human hair gets into that mechanism. That's tremendously huge compared to what we need to have it be able to roll across. So contamination is definitely an issue for us as well. Have some examples of things that we've developed as some of these space mechanisms. So I mentioned the solar array for space station, and here's how it deploys on our orbit. You may not have remembered this kind of thing, but it has a deployable mast that has hundreds, maybe thousands of little joints that are deploying out. Motorized piece. It had those release mechanisms on it as well to hold this in place before it was moved out, and all the joints and panels as this thing deploys. There are that spacecraft separation that is very explosive. So these are would be two, the rocket and the spacecraft connected together, and then all of a sudden it is not connected. It's a clamp that holds it together and releases. Things that move continuously. These are a scanning mechanism. This one was actually on a instrument that is measuring the humidity of the clouds across the world, and it scans across that. Some more simple deployments off of a large solar array that already deployed, and then some other deployments off of that, and some other ones that are antennas that just pop out and curl up as a communication antenna or something else. So I think that is all. There's a bunch of other, you can go on YouTube and find all kinds of other deployments and examples of space mechanisms if you look. So that's all I have.